Arithmetic sequences defined explicitly. So in our last set of notes, we defined our arithmetic sequences recursively, meaning we needed to know all the previous terms. We needed to know the previous term to get the next one. Like I had to know what the seventh term was to be able to get the eighth one. Today, we're going to be coming up with a way of getting the term without knowing any of the previous. An explicit rule, so here we're talking about an explicit rule for a sequence, defines the nth term of the sequence as a function of n. So if I want the 10th term, I can just plug in a 10 and it'll tell me what that 10th term is. I don't need to find terms 1 through 9 to be able to find the 10th term. So an explicit rule is super useful because you don't need to find all the previous terms. To find the next one. Okay. And so to get this idea of an explicit sequence, we're going to look at a sequence that we looked at in the last set of notes. Here we have these figures. I'm going to go ahead and I'm going to write the number of blocks in each figure. Figure 1 has 1 block. Figure 2 has 3. Figure 3 has 5, so forth and so on. So we know here my common difference, I go up by 2 each time. Okay. Sorry. So let S of n equal the number of squares in the nth term. So is this sequence an arithmetic sequence? Yes. How do you know? Well, it has a common difference. And it asks, so what is a common difference? It has a common difference of 2. Okay. So this common difference idea can be related to the stuff we did before, since it goes up by the same amount each time. We say it has a constant rate of change. Since it has a constant rate of change, we know it's linear. So all of our rules for writing linear functions apply here. Okay? We just need to make sure we understand how these ordered pairs work. Meaning figure 1, so that would be the first term in the sequence, gives me a 1. So this would correspond to the point 1, 1. Figure 2, the second term in the sequence, gives me a 3, so that would be the point 2, 3. Figure 3 gives me a 5, so that would be the point 3, 5, so forth and so on. So we want to write an explicit rule for S of n in terms of n, and then find S of 13 without having to find all the other terms. So to write this explicit rule, I'm just going to use my linear equation steps. We know its common difference is 2. The common difference of 2, this common difference of 2 is that rate of change or slope. It's going up by 2 each time. And then once I know the slope, all I need is one other point, and I can use y minus y1, mx minus x1. Okay, big note of caution here. Your book does it a different way. Okay, book does it a different way. So if you look at your book, they're going to have this different equation, which I will tell you, it's useful. It does work. The equation does work, but the hard part is no one ever remembers it. No one remembers that equation. Whereas this guy, we use all the time. We've been using it for the past 2 chapters, and we're going to use it again in chapters to come. So this guy we remember. A function, an equation isn't useful unless you can actually remember it to use it. Hey, so we're going to use, I'm going to do it differently than the book, but we're still going to get the same equation. It's just going to look a little different. Okay, and we'll talk about that difference in the next problem. Okay, all right, so here are my equations. So I just need to plug in my slope of 2 over here. So my slope is going to be 2. And then I just pick one of these points. I'm going to use the point 1, 1. I could have used the point 2, 3. I could have used the point 3, 5. You can use any one you want. But so I'm going to replace my x1 is 1 and my y1 is 1. So I'm going to write my equation. Y minus y1, 1, equals 2x minus x1, which is 1. Now I distribute this in, 2x minus 2, and I want to solve it for y, so add 1 to both sides. So y equals 2x minus 1, but I want to write it as s of n. So I need to rewrite this. It's going to be s of n equals 2n minus 1, because again, we want it as s of n. So basically, just use your x's and y's till you get to the end, and then write it as a function notation. What's lovely about this function is if I want to know what the third term is, I just put a 3 in here. 2 times 3 is 6 minus 1 gives me the 5. If I want to know the 100th term, I don't need to find all 99 terms before it. So here, if I want to find what's s of 13, what is the 13th term? I take 2 times 13 minus 1, so 26 minus 1. The 13th term is going to be 25. I don't need to count by 2's all the way up to the 13th term. Okay. All right, so the explicit rule is super useful, and I find it way more useful than the recursive rule. So next here we have an arithmetic sequence is defined. Here's our explicit rule. Okay, this is the way the book does it. I'm just going to show you the equation. It's f of 1, n minus 1. Oh, that should not be, sorry, that should not be an equals, plus n minus 1 times the common difference, times d. Okay, so it's the first term plus n minus 1, whatever. Okay, so this is how the book writes it. If I was to simplify this, distribute, and we'll do that here in a minute, you'll see it's the same as like writing it this way. It just looks slightly more complicated. So I just wanted to show you that the book's functions might look slightly different, but they really are the same thing. They're just written differently. Okay, so here we have an arithmetic sequence is defined by the explicit rule for n from 1 to 10. So this is anywhere, this is, again, this is the first term. So we're going for the first term to the 10th term. Okay. But since it's a sequence, again, we're only dealing with the numbers 1, 2, 3. So it's none of those in-betweens, like we don't put a 1.2 in. So since it's a sequence, it's only what we call the counting or natural numbers, depending on your text, meaning no in-betweens, since it's a sequence. They want us to find what is the first term. Well, to find out the first term, I just put a 1 into this. So I'd have 12 plus 1 minus 1 times 9. 1 minus 1 is 0 times 9 is 0. So my first term is just the 12. The first term is 12. What are the domain and range values of the function? Well, the domain, again, they told us is like the numbers 1 to 10. They give us that right here. But really the domain is just strictly those numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the domain. Because it's a sequence, we can't include any of those in-betweens. Now, for the range, I'm going to need to put those numbers in. Okay, so for the range, I'm going to go ahead and I'm just going to create my table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to go ahead and put those numbers in. We know the first term is 12. The second term, f of 2. So I take 12 plus 2 minus 1. That would be 12 plus 2 minus 1 times 9. So 12 plus 2 minus 1 is 1. 12 plus 9 is 21. Okay. F of 3, so now we do 3. 12 plus 3 minus 1 times 9. 3 minus 1, here, let's zoom in over here. 3 minus 1 is 2 times 9 is 18, so 12 plus 18. If you notice, we're just going up by 9 each time. Okay, so we go up by 9 for 18, so that'd be 30, up by 9, 39, up by 9, 48, up by 9, 30, 57, and then 66, 75, 84, then 93. Okay. Which I could get. F of 10, I would need to take 12 plus 10 minus 1 times 9. So 12 plus 9 times 9. 81 plus 12, 93. Okay, so there's my range. My range then would be these numbers: 12, 21, 30, 39, 48, 57, 66, 75, 84, and 93. There's my range. So in this part C, an arithmetic sequence is equivalent to a linear function with a restricted domain. What we mean by that restricted domain was this that we talked up here. We're just talking about those counting or natural numbers since it's a sequence. We don't look at any of those in-betweens. We want to show that the explicit rule for the sequence can be written as a linear function. Basically, we're going to rewrite this rule. So f of n equals, it was 12 plus n minus 1 times 9. Okay, we're going to go ahead and distribute this 9n. 12 plus 9n minus 9. And then I can take the 12, and that's a negative 9. Negative 9. So I'd end up with 9n plus 3. So there's my function. I can tell that the slope is there is 3. So that's my slope, or my common difference. And then my y-intercept there is 3. That's not my first term. My y-intercept, because first term would be actually 9 plus 3, which is 12, which is what we got over here. Because I put a 1 in here for n, not a 0. Okay, so we are going to write our functions are going to look, our arithmetic sequences are going to look like that. Just because it's easier to remember, okay, and we're used to that. So here we have, in task 3, the photo shows the cost of admission to an aquarium for a group. Let f of n equal the total cost in dollars of n admission tickets. What are the first 3 terms of the sequence? So first we're going to write the first 3 terms. So I'm going to go ahead and I'm going to do it as a table, but we'll go this way. Term 1, 2, 3. First 3 terms. $30 for the first person. $11 for each individual. So 2 people would be 30 plus 11, 41. Add another 11, 52. So my common difference here is 11. Write an explicit rule for this sequence. So again, I'm going to use the y minus y1, mx minus x1. We go up by 11 each time. So my slope is 11. And then I'm going to use the point 1, 30. X is 1. Y is 30 for my x and y. So y minus y1 equals 11x minus 1. Okay. So here we'd have y minus 30, 11x minus 11. Add the 30 to both sides. Y equals 11x plus 19. So then now we would write that as f of n, 11n plus 19. Write in a recursive rule. If you remember our recursive rule, we have to list the first term. The first term is 30. And then now, to get every term after that, I take the previous term, n minus 1, and add 11. So this is just flashback to last section. First term is 30, and then I take the previous term and add 11. What is the cost for 20 tickets? Which rule did you use to find the answer? Explain your choice. Well, if I'm going to use this rule, I only have for 3 people. I would have to keep going for 4, 5, 6, 7, all the way up to 20. Or, if I use this guy, I just figure out what's f of 20. 11 times 20 plus 19. I come in, I grab my calculator. Sorry, my calculator's missing. 11 times 20 plus 19. Enter. 239. $239. We use the explicit rule. Why is it my choice? Explicit rule because I didn't have to find f of 4, f of 5, f of 6, ... I didn't have to find all of them up to f of 20. Okay, so task 4. Consider the sequence defined by the recursive rule. So here's our recursive rule. First term. So this is g of 1, first term. And then to get to my next term, I add 18. So there's my common difference. There's my difference right there. Suppose you want to write an explicit rule for a sequence. What information do you need to write the explicit rule? Well, we need the common difference, which we have. We need the common difference, and we need at least need one term. Need to know one term and where it's located, which we have. First term is 120. Can you use the recursive rule to find the values that you need to write the explicit rule? Yes. We know the first term is 120, and the common difference is 18. Now let's write my explicit rule. So again, we're using y minus y1 equals m x minus x1. We know the common difference is 18. That comes from here, goes up by 18 each time. And then we know the first term is 120. So that'd be the ordered pair 1, 120. So first term is 120. So now we go ahead and plug it in. Y minus 120 equals 18x minus 1. Y minus 120, 18x minus 18. Add the 120 to both sides. So g of n equals 18n plus 102. So there is mine. Check your explicit rule by verifying that it gives the same value as the recursive rule for g of 3 and g of 5. Okay, so first thing we need to find g of 3 and g of 5 for this one. So let's go ahead and let's find it. We only have one. We have to find 2, 3, 4, and 5. I'm going to use my calculator to help me out here. Oh, sorry. You don't want it to take up the whole screen. Do it this way. Okay, so you go by 18 each time. So we start with 120, up by 18. Second term is 138. Plus, now I just hit plus 18. Gives me 156. Hit enter again, 174. And then the fifth term is 192. Okay, now let's go ahead and let's use our rule. So to find g of 3, I just plug a 3 in. 18 times 3 plus 102. 18 times 3 plus 102 gives me 156. Is that what I got up here? Yeah, we'll go side by side. Yep, 156. Can I go smaller? Yeah. All right, now we need to find the fifth term, g of 5. So it would be 18 times 5 plus 102. 18 times 5 plus 102 gives me 192. Was that my fifth term up here? Yep, it was. We're good. 192. Yep, it worked. Katie says that an explicit rule for the sequence g of n is given by this. Is her rule correct? Explain why or why not. Well, I'm going to go ahead and I'm going to rewrite this. I'm going to put together like terms. So g of n equals 18n plus it'd be 119. We had 102. So is it? So this is 119 as opposed to our 102. No. First of all, the first term doesn't even work. If I find g of 1, 18 times 1 plus 119, 18 times 1 plus 119. The first term is 137. The first term should be 120. So explain why or why not. Nope. What doesn't work? Common difference is correct, but terms are not. But first term is not. Basically, she inaccurately used the book's version of the arithmetic sequence. So here we have a graph that shows an arithmetic sequence. Write an explicit rule for the sequence. Then use the rule to find f of 8. Okay, so again, y minus y1 equals mx minus x1. So I'm going to use 160 for my x1, y1. Now I just need to find the slope. So to find the slope, rise and run. So this goes up by or change in y over change in x. Oh, that's slope, not y. All right, so my y goes from 90 to 60. So I'm going to take 90 minus 60, and then from 1 to 2, 2 minus 1. So my common difference is 30. So my slope is 30. Now we know all the pieces. We can write it in. 30x minus 1. So distribute that 30 in. Add the 60 to both sides. So y equals 30x plus 30. So that would be my f of n. We want to write it again. F of n, 30n plus 30. Use it to find f of 8. 30 times 8 plus 30. 30 times 8 is 240 plus 30, 270. I don't even have to find it, but if I look at my graph, they actually have this marked out. Yeah, that looks about 270. Okay. All right, here's our last task for today. A plumbing company creates a fee chart for their labor charges. What is the total charge for 9 hours of labor? Now, I could go ahead and just continue this out. 6, 7, 8, 9. Okay, and that wouldn't be too horribly hard. But instead, I'm just going to write the equation so I can plug it in. My common difference here, 175 to 125. Okay, 175, was it 50? Wait. Yeah, 50. No, 125 to 75? Yeah, it's still 50. Sorry, my pad is glitching up. Okay, yeah, that went up by 50. And my first term is 75. So y minus y1, y minus 75 equals 50, x minus 1. Now, 9 hours of labor, number of hours of labor, so that's my input. So I'm going to input a 9 in there for my n or my x. So f of n minus, I'm going to leave it as is. Oh, sorry, that should have been a 50. N is 9 minus 1. Oh, I'm doing too much at once, guys, here. I'm sorry. Let's back it up. Let's just write my equation. Y minus 75, let's distribute 50x minus 50. Add the 75 over. F of n equals 50n plus 25. Now I need to find f of 9. 50 times 9 plus 25. 50 times 9 plus 25. 475. $475, which I also, again, could find from just going up by 50 each time here to find 6, 7, 8, 9. So 475 looks reasonable.